Hello, my name is Eva, and in this presentation I would like to introduce my Summer of HPC project, which was focused on parallel computing demonstrations on Wee Archie. Wee Archie, which you can see on the picture now, is a suitcase-sized supercomputer that is built out of 18 Raspberry Pi nodes, and it was designed to illustrate what a supercomputer looks like and how it can be useful. The goal of this project was to develop some new programs that could be run on Wee Archie, for example on science festivals, to demonstrate how parallel computers work. The reason we need such programs is that we want to motivate kids in an attractive way to learn more about parallel computing. And we also want to attract new people to the field of computer science. As a starting point, we needed to learn how to program the LED lights that are connected to each Raspberry Pi node on Wee Archie to be able to do real-time visualizations later. We needed to start from scratch with simple functions such as printing letters or images onto the LED lights, because all the programs that have been developed so far for Wee Archie did not really make use of these LED lights. Later on, we could make more complicated programs such as scrolling messages across the nodes of Wee Archie. Once we were familiar with how to program the LED lights, we started thinking about how to use them to visualize the basics of parallel computing, such as the difference between sequential and parallel computations, or some communication patterns. For experienced programmers, these are very easy to understand, but have you ever thought how would you explain these to inexperienced young kid who have actually never heard of parallel programming before? So we wanted to start with something really simple, and the first application we developed was a database search, which is by nature embarrassingly parallel application, and it allows the user to search for any string in a database of tweets, and it collects some information about the tweets that contain the given string. Let's have a look at the video. The program is run from the command line from a laptop. The user gives a string and also the number of workers. And now you can see the Wee Archie. The master node reads the searched string. It wraps it up as a message and sends it to the working nodes. Each of them then processes its part of the database, and when they are finished, they send the results back to the master, who collects them and prints them to the output. So what parts of the parallel computing does this illustrate? At the beginning you could see a broadcast of the string, then you could see the distribution of work across the working nodes, and at the end the master gathers the results back and prints it to the output. The second application we developed was a bit more complicated. It's called a bingo game, and it aims to also demonstrate point-to-point communication. The principle is similar to a standard bingo game that you probably know. So each working node is at the beginning given its own private letter, and then the game proceeds in rounds. The master in each round distributes a new randomly picked letter to the workers, and the workers check if the newly obtained letter matches their own letter, and then they need to communicate with others across rows and columns to see if they had a match and if the game is over. Let's have a look at the video. The program starts from the command line again. It reminds the user to fill in the input file, and if that is finished, the game starts. The master node loads the letters from the input file and then performs a scatter operation so that each working node now has its own letter, and then the master picks random letter and does broadcast to the working nodes, and they check if they have a match, and if they do match, they print a smile. Now a bit faster, we can see how the game proceeds. Also, if some of the nodes on the left side or on the top have a match, they also check with their neighbors if they have match to see if the game is over. Now we can see that the third row from the top had a match and the game is over. So what does this game illustrate? As you can see at the beginning, there was a scatter function, and then in each round a broadcast, and to check if the game is over, there was a point-to-point communication. To sum up, as an outcome of this project, we have a set of functions or demos for the LED lights that can be used in any Python program, and we have the two main simulations that you have seen already. Besides that, we also have some additional simulations that are mostly just for fun, such as this rainfall screensaver that can be used if Wee Archie is idle and no one is currently working with it. Because of the limited time frame, obviously we did not manage to do everything, and there's many things that can be done, such as more demos for the LED lights and also more simulations to cover some more advanced parts of parallel computing, for example, all-to-all communication. To finish the presentation, I would like to thank all the people from Edinburgh Parallel Computing Centre who helped me with the project and without whom I would never be able to finish it. Thank you very much for your attention.